today's video, we'll cover the power rule. This is the third exponent rule that we are going to learn about. Our goal today will be to use the power rule of exponents to simplify expressions. So the power rule states that when an exponent is being raised to an exponent, we can simplify by multiplying the exponents together. So if you look down at this example on the left, we've got the base of 6 being taken to the second power, and that all is being taken to the third power. So this 6 squared is being taken to the third power. One way to think about this is 6 squared being multiplied 3 times. Right? If we're taking 6 squared to the third power, we're going to multiply it by itself 3 times. So we can actually turn in this power rule to the product rule. When we've got bases that are the same that are being multiplied, we can add the exponents. So if we added all the exponents here, 2 plus 2 is 4, plus 2 is 6. We get 6 to the power of 6. So one way of thinking about the power rule is just the product rule. However, the power rule is makes it a little bit simpler for us, because all we really have to do, instead of writing it out and adding up the exponents, is just multiply the powers that are being just multiply the two powers together. So if 6 squared is being taken to the third power, then we can just say 2 times 3, and we know that 2 times 3 is 6. So we're just pretty much multiplying the exponents together. An abstract way of thinking about it is a to the m power, all being taken to the n power. We can just multiply m and n, which are the two exponents. Example number 1. So here we have 4m to the 8th power, p to the 8th power, times q to the negative 2nd power, and that is all being taken to the 4th power. So our first step will be to identify the number of bases. And we're going to include the constant as one of our bases that we're identifying, and I'm going to actually just box it, that way you know. It's a little bit different than our variable bases. So we've got 4 bases, and 3 of them are variable bases. So p, or m, p, and q. Now our second step is to express the expression with the multiplication of our exponents. So what was the exponent on the 4? Well, the exponent was technically 1, so we can write this as 4 to the first power times 4, m to the 8th power times 4, p to the 8th power times 4, and q to the negative 2nd power times 4. So we pretty much distributed this power to all of our powers. Now we're just multiplying. Now let's go ahead and simplify. Our third step is to simplify the multiplication and write as positive exponents. So 4 to the first power times the 4th power is just 4 to the 4th power. 8 times 4 is 32, so we've got m to the 32nd power. We've got p to the 32nd power. And we've got q to the negative 8th power. So this is a negative exponent because negative 2 times 4 is negative 8. Now because we have a negative exponent, we've got to convert it or write it as a positive. So I drew my fraction line, that way I know that this q to the negative 8th is in the numerator right now. So to make it a positive exponent, we just have to move it to the denominator. When we do that, what we get is 4 to the 4th, m to the 32nd, p to the 32nd all stays, and now we've got a positive q to the 8th power. Our last step, our fourth and final step, is to evaluate the constant base. So the base is 4, and it's being taken to the 4th power. So 4 to the 4th power is 4 times itself 4 times. Which is 256. So 256 m to the 32nd power, p to the 32nd power, all over q to the 8th power. Example number 2. we have a constant of -3, a base of y, and a base of z. The power that we're going to use to multiply is -2. So when we write this as the multiplication of our exponents, we've got -3, and we're going to include the negative with the base in these examples. So when you see the constant is a negative and it's in these larger parentheses, go ahead and assume that the negative is part of the base in these examples. So we got -3 to the first power times -2, y to the 0 power times -2, and z to the -4th power times a -2. We can go ahead and simplify the multiplication of our exponents. So we've got -3 to the -2nd power, y, 0 times -2 is 0, to the 0 power, and z, -4 times a -2 is a +8. So the multiplication of our exponents is just pretty much multiplying the numbers, so all the rules for multiplication stand. Negative times a negative is a positive, anything times 0 is 0, and a positive times a negative is a negative. Now we can go ahead and write this as our bases as positive exponents. So we've got to convert this to a positive exponent, and that is the only one. So when we do that, what we have is y to the 0 power, z to the 8th power, over -3 to the +2nd power. Now we know that anything to the 0 power is 1, so we can rewrite this as 1 times z to the 8th power over -3 to the 2nd power, which is essentially just z to the 8th power over -3 to the 2nd power. And our final step is to multiply our constant base. So -3 times itself 2 times. Negative times a negative is a positive, and 3 times 3 is 9. So we've got 9 on the denominator, all over z to the 8th. Example number 3. I'm going to go a little bit faster now. So we've got 4, y, z, and x. We can write this as 4 y to the first times 6. See, they don't have numbers, so then we know the exponent is 1. And x to the 7th 2 times the 6th. So we can rewrite our multiplication as 4 to the 6th power, y to the 6th power, z to the 6th power, and x to the 42nd power. The last step here is just to simplify the constant base, 4 to the 6th power. Is 4,096. So we get 4,096, and put these in alphabetical order: z to the 42nd power, y to the 6th, and z to the 6th. Example number 4. We've got our base here of a -1. We've got m, p, and q. So we've got -1, 1 to the 8th power, -5, 6 times 8, and 0 times 8. So we've got -1 to the 8th power, m to the -40th power, p to the positive 48th power, and q to the 0 power. We've got one negative base, or one negative exponent, so we've got to move the base over the fraction line. When we do that, what we get is a -1 to the 8th power, p to the 48th power, and q to the 0 power is just 1, so we can just multiply this all by 1, over m to the positive 40th power. Now we can go ahead and just simplify the constant here. So -1 to the 8th power is negative 1 times itself 8 times, you can go ahead and make a note in your notes that any negative base, that's better, any negative base taken to an even exponent, comma, will be a positive value. So we've got a negative base here of 1 being taken to an even exponent, so it's going to be positive, and then 1 times itself 8 times is just 1. So in the numerator we're left with p to the 48th over m to the 46th. Two more examples. Oh, actually just one more example. Example number 5. We've got a negative base. We've got x, y, and z. We can rewrite this as negative 1 to the 3rd. X, negative 2 times 3. Y is 4 times 3. And z is 1 times 3. We can simplify this as x to the negative 6th, y to the 12th, z to the 3rd. Now we can go ahead and write our negative exponents as positives, so we're just going to have to move this one over the fraction line. What we get is negative 1 to the 3rd, y to the 12th, z to the 3rd, over x positive 6th. And now you can make one more note that a negative base to a odd power will be a negative value. Kind of sloppy. But we got a negative base being taken to an odd power, so it's going to be a negative number, and 1 times itself 3 times is 1. So we just got negative y to the 12th, z to the 3rd, all over x to the 6th. Good luck on the homework.